Hello everyone, this video is called Translation Units and you will learn about translation units, what they are and how they are created. This video also assumes basic knowledge of Yang modeling language. A translation unit is a set of small Java classes that are called handlers. There are two types of handlers, readers and writers. When you open a router configuration and scroll through commands, each command usually has its own reader and writer. A translation unit is therefore a set of readers and writers that are specific for a certain type of commands. A good example is interface units. In here you have handlers for various types of interface configuration, sub-interface configuration, and so on. First thing that we do when we are creating new handlers is define data representation of router configuration in OpenConfig Yang models. OpenConfig is a set of Yang models that was created mostly by Google to simplify device configuration by unifying it across various vendors. We use OpenConfig Yang models as northbound REST API in our UniConfig product. Now, if we don't find anything suitable in OpenConfig, we create an extension that augments original model. We never change original OpenConfig model to avoid merge conflicts when we update them. As we are based on Open Daylight, we can take advantage of a project called Yang Tools that takes Yang model, generates Java builder classes from them, and also generates REST interfaces. Now we are getting to the part where we can see why we call translation units actually translation units. They translate device configuration to a data structure described by Yang. The reason behind using OpenConfig is to unify device configuration and handle it in UniConfig regardless of device vendor type or version. If a command changes from one device version to another and we want to support both, we need to have handlers for both versions. Let's talk now about how this command is read from the device and how it is sent to the device. There are two ways how to connect to the device and handle its configuration. One is via netconf protocol. This is supported directly in Open Daylight. In this case, the handlers need to do model-to-model translation from device-specific Yang models to OpenConfig Yang models when reading, and from OpenConfig models to device-specific models when sending configuration to the device. The handlers for netconf communication are stored in a project called Unitopo Units, and they are written in Kotlin. Since not all devices do support netconf, we implemented another way, a simpler way how to handle the communication with the device. It's through plain CLI. In this case, we send plain text commands to the device and read its plain text response. The handlers for CLI communication are stored in a project called CLI Units, and they are written in Java. We also use chunk templating for string manipulation. Handlers are tied to Yang models, meaning if you implement a reader and writer, you implement it for a Yang element. You can register a handler to a Yang list or a container. This structure of handlers usage and registration is tied to Honeycomb project from FDIO. Let's take a closer look at readers. List readers have a method getAllIDs that should return list keys for the desired list. In the case of interfaces, this method should return names of the interfaces. The Yang will tell you which element is the list key. Container readers have a method readCurrentAttributes. In our example case, interface dampening config reader should return dampening information about the specific interface. In case of CLI, the reader sends a command to the device to retrieve desired configuration. For example, in case of IO6R and interface config, it sends show configuration include interface. Then the output is read and the information desired is parsed using regular expressions. In case of netconf, the reader sends to the device a Yank instance identifier that marks a specific position in a Yank tree that we want to read, and the device sends back a Yank data starting at the Yank instance identifier. All writers need to implement create, update, and delete methods to cover all operations. Create operation will call create methods on all Yank elements from the top to bottom. Delete operation is called on all Yank elements from bottom to top. This means if we are writing an interface, first the interface list item will be created, then config container, and then leaves in the container. When we are deleting an interface, the leaves in config container get deleted first, then the config container, and at last the interface, the list item. You can override this behavior by specifying custom ordering of handlers during their registration. Writing in case of CLI very much resembles reading. Yank data must be translated into device-specific command, and this one is sent to the device. When writing using netconf protocol, the handler sends a Yank instance identifier along with Yank data to the device. Both need to use device-specific Yank models. For further information about translation units, go to docs.frinx.io or to our GitHub called Frinx.io. Thank you.